Yes, are you getting this? Okay, now I'll explain about the sp hybridization. Again, carbon atomic number is 6. Electronic configuration 1s2, 2s2, and 2p2. And now you can see that there are 2 electrons only, which are unpaired. But according to VBT, valence bond theory, only those electrons which are unpaired that should make bond. It means I should have 4 unpaired electrons. Yes or no? So one electron from 2s get degenerated, means excited here, and now the from the ground state this carbon is in the excited state, where it has now 4 unpaired electrons, now capable of making the 4 electrons, right? 4 bonds. And this is a 2s orbital here. It's a 2px, 2py, and 2pz orbital. In case the carbon is making triple bond, it undergoes sp hybridization, means one s and one p undergo the intermixing, and the other two, these two, remain unhybridized. When it is unhybridized, after intermixing, they will have same shape and same energy. We call this is a sp hybridized orbital. Okay, sp hybrid orbitals. And these hybrid orbitals align themselves according to VSEPR theory at 180 degrees as far as possible. One electron here and one electron here. And other two unhybridized orbital remain perpendicular to this and other perpendicular to both of this. These are the unhybridized orbital. Understood? Droid. Then I will explain about the ethine molecule where it is making triple bond. Okay. Now I'm talking about the second carbon atom now. In case of ethane, I have two carbon atoms, right? And now second carbon atom. This is the sp hybridized orbital, overlapping head to head and forming a sigma bond. And there are two orbitals. One is this, other is this, which are unhybridized orbital, right? So what happens here? Here the s orbital of the hydrogen overlap head to head and form a sigma bond, right? And here also the s orbital of hydrogen overlap and form a sigma bond. Now this electron and this electron, this orbital here, side overlapping takes place here and forms a pi bond. This and this forms a pi bond. Understood? So one sigma and two pi bonds are formed. So what I find here is hydrogen, carbon, carbon triple bond. So between the two carbon atoms, there is a one sigma bond and two pi bonds are formed. Draw it. Right. Understood. So next one is now Sp3 D hybridization. Sp3 D hybridization. In this case, I am taking an example of a PCl5, phosphorus pentachlorate. Phosphorus, atomic number is 15, neon complete, 3s2 and 3p3. Here 3D is empty and phosphorus is making 5 bonds here wherever we have these 3 unpaired electrons. This is the ground state electronic configuration, excited state, neon complete. So this electron, one electron get excited from 3s to the 3D. Can you see that now we have 5 unpaired electrons? These orbitals have different energy and different shape. But after intermixing that I will now show you, they will have same shape and same energy. And that's what I say it is a hybridization. So 3s orbital is spherical, 3p orbital are double shape. It's 3px, 3py, and 3pz. And this is the dz square. Remember, we discussed the dz square orbital. Yeah, x, y, and z. So it's a 3d z square. After intermixing, they will have same shape and same energy. 1, 2, 3, 4, and 5. Yeah, yeah. You done all? Yeah. Okay. So these 5 orbitals are now will align themselves in such a way like this. This is a trigonal bipyramidal. It's a phosphorus here, one orbital, second orbital, third orbital, one above the plane and one below the plane. All these are now Sp3 D hybridization. And now since I'm making bonding with the like chlorine in case of in case of chlorine, the chlorine has a p orbital that is involved in bonding, right? One unpaired electron. So that chlorine p orbital will overlap here and form a sigma bond at all the 5 points. It will be like that. Understood? Done. Right. So in case of the PCl5, it is the sp3 D hybridization. Now talking about the next one, sp3 D2 hybridization in case of Sf6. Sulfur, atomic number 16, right? Electronic configuration neon complete, 3s2, and like that. Now it is making six bonds, so it will need six unpaired electrons, right? So electron jump from 3p to the 3d. By that way, it will acquire four unpaired electron. Now from here, right? This is the ground state electronic configuration, and this is the excited state electronic configuration. So like that, 1 2 3. Now I have a six unpaired electrons. Note it down. Done. Okay. So now we have one is the s orbital. There's a 3s orbital here. Now we have a 3p orbital here, like this. It's a 3px, 3py, and 3pz. Then we have two orbitals. One is the dz square, other the dx square minus y square. X, y, and z. 3d x square minus y square. Dx square minus y square. Okay. Yes, Advait. After intermixing, that will have now same shape and same energy. Okay. Sp3 D2 hybrid orbitals. Advait. Yes, Advait, can you hear me? Advait, can you hear me? Okay. So these six orbitals will now align in the octahedral geometry. It's sulfur here. 1, 2, 3, 4. one above the plane and one below the plane. These all are now sp3 D2 hybrid orbitals with one electron each in these orbitals. Note it down. Yes, are that done? Yes, are that done? Hello, Adi, can you hear me? Right. So in case of an SF4, SF6, this fluorine p orbital will be overlapping here. Got it? Fluorine has a p orbital that is unhybridized here, form a sigma bond here. Understood? Understood? Yes, Advait, can you hear me? Hello, Advait? Advait, can you hear me? Okay. Till now, any doubt? So I had discussed Sp3, Sp2, Sp, Sp3D, Sp3 D2 hybridizations. Understood? Yes or no? Okay. Now I'm telling you a shortcut method to determine the hybridization. Advait, now you can hear me? Advait, can you hear me? Advait, can you hear me? Yes, Advait, can you hear me? Okay, no problem. Join me again. Advait, join me again. Advait, join me again. Rejoin. Now you can hear me? Adit, can you hear me now? Adit, can you hear me? Okay. Now I'm going to tell you about the shortcut method to determine the hybridization. 1 upon 2. Wait. My pen is not working. Wait a minute, please. Yes. 1 upon 2. Okay. This one. Right. I said after intermediate octahedral geometry is clear. No. This much was okay up to this. Right. So those 6 orbitals will align themselves here. Sulfur here. 1, 2, 3, 4. One above the plane and one below the plane. All these are sp3 D2 hybrid orbitals, and they are like this. So it is a sp3 D2 hybrid orbitals. sp3 D2 hybrid orbitals. Right? Getting me? And it is combining the fluorine in case of Sf6. So fluorine has a p orbital that is overlapping here. Fluorine has a p orbital overlapping here to form a sigma bond. At all the 6 points, it will be making sigma bonds. Getting me? Getting me now? So octahedral geometry is formed. I hope it's very clear now, right? Okay. Now, I'm giving you shortcut formula to find the hybridization. Hybridization is equal to 1 by 2. Number of valence electron in the central element. V stand for number of valence electrons in the central element. Plus M. M for monovalent. Monovalent means those atom which can share only one electron to make a bond. Plus negative charge minus positive charge. Right? To determine the hybridization of any compound, right? H for here hybridization. V stand for number of valence electrons. M stand for number of right? where M stands for number of unpaired electrons. Now, suppose I want to find out the what is the hybridization of carbon in the in this carbonatine. I want to find the hybridization in the carbonatine. What is the yeah? What is the hybrid? What is the hybridization? Right, of carbon in the, so it is equal to 1 upon 2. Central element is the carbon where I have 4 electrons and valence electrons. Right. Monovalent is 0 here. Oxygen is the divalent. Oxygen cannot right. Oxygen is is a divalent. Negative charge is 2. Negative charge is 2. Right. 2 negative charge. Minus positive charge is 0. So 6 by 2 means 3. 3 means sp2. It is having sp2 hybridization. Yeah. If it is 4, it will be sp3. If it is a 5, then sp3d. If it is 6, then sp3d2. See? 1 plus 3 plus 1. 1s and 3p total is equal to 4. Yeah. Right. No, not like, or it is always for the central element always. Right. Now suppose I had to calculate the hybridization of phosphorus in phosphoric acid. Right. So hybridization is equal to 1 by 2 into 1 by 2 into central element is the phosphorus where I have 5 valence electrons. Monovalent are 3 because hydrogens are 3 in number. Negative charge 0, positive charge 0. So it is a 8 by 2, that is equal to 4. 4 means sp3. sp3 hybridization. Understood? Ajay, tomorrow 9 o'clock, my 9 o'clock. Okay? My battery is about to die. it may it may shut down by itself, right? So time is about to end. By that time we can do more practice. Now if I want to calculate the hybridization of sulfur in Sf4, can you try? Yeah, try now.